Okay, welcome everybody to the lab tour. We're going to take a walk through the lab today, show you where the HeiQ lab is located. We have a guide, Dr. Renzo Raso, who is awaiting us at the lab. Let's see. There he is.
Okay, let's go. Let's go. So, hi everyone, welcome to our lab. My name is Renzo Raso. I'm Director of Research here at HeiQ Materials in Schlieren, which is situated close to Zurich in Switzerland. It's an honor for me to introduce you to our central research, development, and testing lab. As in the past year, we have developed here some groundbreaking technology for textile application, and the new one are in preparation. Let's have a look. I would like to start the journey with the chemistry and formulation lab. Here, dedicated scientists are working every day for the generation of new functionalities. These functionalities include durable water repellence, DWR, thermoregulation, odor control, antimicrobial treatment, and also antiviral treatment. Now, after the functionality, the active component has been developed, discovered, it has to be stabilized and formulated in a proper formulation that is able to withstand travel over the Indian Ocean in a container ship. So basically, the work that we are doing here is to stabilize and formulate the active compound that still keeps its functionality when it arrives at its place of use. Now that we have developed the functionality and mixed it in a proper formulation, generating number of high-performance textile treatment, we want to apply this new formulation on a proper textile. And for that, we have a modern textile library here, where we can choose the proper textile for the single functionality. You can imagine that the DWR textile will have other requirements compared to a thermoregulation technology, which is then direct on the skin. Now, on one side we have the formulation, on the other side we have the textile. We want to combine them. For that, go into the application lab. So what possibilities that we have to apply the new developed formulation, new developed product on a textile is by using a lap padder. Basically, the textile is squeezed between these two wheels that contain the formulation. After it passes through, it is put in an oven for drying and curing. After that, the textile is ready, finished, and can be tested. Now, this was the padding application. In case you want to have exhaust application, we can simulate that with this ugolini. This system is related to the washing machine, with the difference that its purpose is not to remove compounds from the surface, but to put some functionality on it. So this is the ugolini. Very often we get requests from our customer to make field tries or wear tries. For that, we need large volumes of textile. As you can see here with my colleague Daniel, we are producing large quantities of treated textile with this pilot plant, which works in full arm. We can make the round. As the textile is passing through the path where it contains the formulation, it's then squeezed between the two wheels and passes in an oven. After that, the textile is ready to be shipped around the world. Now, one of the key performance indicator of our functionalities, of our treatment of the textile is the outstanding wash durability. To assess this, we have a professional washing machine. With this washing machine, we can simulate any norm which is required by the customer. So we arrived at a stage where we have the new formulation applied to the textile, and we want to assess its characteristic and performance. For that, we walk to the analytics and the testing lab. As I mentioned before, the colleague in the R&D are developing, among others, also powerful antimicrobial. One of the main components in some of our antimicrobial is our silver component. And to monitor the silver on the textile, we use this kind of equipment called atom absorbance spectrometer. With this, we are able to detect at a very, very low level the presence of the active component that allows us to have a very high quality standard and to have a strong tool for making new developments. Now, during the pandemic, the antimicrobial became very important as a protection for pathogenic entities like bacteria and viruses, I mentioned. But originally, the silver technology was developed for odor control. In fact, in the beginning of HeiQ, we were using silver-based compounds to fight the formation of smell on garment originated by bacteria. So we wanted to control the bacteria. But over the time, the requirement for having odor control without the need of using biocide has become more and more important. And for that, we developed a whole family called HeiQ Fresh. To develop these kind of products that control the smell generating molecule, we have this GC headspace that my colleague Olga is working with. So basically, if you allow, Olga, basically what we are able to do is to measure the equilibrium concentration of VOC, a volatile organic compound that generates the smell above the textile. And by measuring that, we are able to develop powerful technologies that eliminate the smell. On the left side, we can see Jona now working on the UV spectrometer, which is actually a very common device that is found in many chemistry labs. But we are able, by using sophisticated colorimetric reactions, to offer to our customer a test, online test for presence and functionality of the very product that we are offering them. So here we have a powerful tool which is combined with colorimetric reaction. The change of color or the formation of color is then an indicator of that very functionality that we are looking for. One last functionality that I would like to share with you, as I mentioned before, is also thermoregulation. Now let's see how Luca is working on the new generation thermoregulation with infrared camera. So we see Luca is now working on the new generation, and I can't tell you too many details, but it looks very promising so far. I would like to thank you for this part and to give the word to my colleague Martin Meyer. He's head of testing.
Yeah, hello, I'm Martin Meyer, head of testing services at HeiQ Materials, and I'd like to show some tests from the two groups, Smart Temps and EWR Eco products. So first here, you have the simple tests, you probably know them. It's just a wetting test and the wicking test. The wetting test is we just check if the fabric is soaking water, yes or no. And you're probably going to see here some difference between the front side and the back side of the fabric. This comes, in this case, because of the print of the fabric. Second test is a wicking test, very simple test, fast test. You just put these samples into water and you measure the wicking that the fabric shows. We already can see here some differences from the left samples to the right samples, and that's what we actually expect. The right samples are treated, the left ones are non-treated. Okay, but most important for us is the dynamic evaporation tests, where we measure evaporation on 2 different temperatures. Cool temperature, 20 degrees, warm temperature, 35 degrees. Elena is gonna show you how we prepare the samples. What you can see is what we call the glove box. That's where we have our 20 degrees. And defined, very important, defined humidity, air humidity. So what she's doing is putting these discs into the box. Now she needs to work with the gloves. It's not because it's dangerous, it's because of the climate. We want to measure at a certain climate, therefore we're using these boxes. So she's adding water onto these filter papers. These filter papers are actually simulating our skin. And afterwards, she will put the fabrics on top of the skin, meaning the filter. So from there, the water evaporates through the fabric. And that's how we measure evaporation of the fabric. We already have the second box running, so you can see the samples are already at testing. Yeah, here we have the higher temperature. The box is turned off now because of the noise. That's why the temperature is not really correct here. But otherwise, you wouldn't understand what I'm talking. So the samples are turning. It's just for having a more equalized result. So this is again our most important test for the Smart Temp product group. So let's go to our other group that I mentioned before, which is the DWR group. I'm going to show you the 2 tests that we're using for this. Yeah, we have here very simple tests. It's called spray tests. Many of you might know this. We got a fabric here, and we just pour water onto this funnel. Just let it pour for, it's like 30 seconds. It's a simple test, it's a fast test. It's very important for us in development that we get fast results and can see if the products that we develop are on the right path or not. You judge like this. So this means this is a spray 100. We do not see any wetting. There's no dark spots. That means we have a spray 100. But then we have a much more sophisticated test. It's called the Bundesmann test. We're using that because it gives much more differentiated results on our fabric samples. So please follow me. It might be noisy because the machine is still running, but I try my best. You see the machine in the background now. It's simulating rain shower. So the height here is 1.60 meters, water drops falling down onto 4 fabrics. Now Sevi is going to show us how we start the machine, and you will see 4 samples running on the machine. What we're simulating here is basically a rain shower. So we have water falling from above 1.60 meters onto these turning samples. You can already see differences on these samples. It looks like 3 of them are really good, but there is one here. You can see wetting already now. So for development, this means this recipe is dead. The judgment is very similar to spray test. I'm going to show you. You got these best on the top and the worst on the very bottom. This is basically a wet sample. What we are aiming for is a grade 5. Also, big difference here is time compared to spray test. This test is running 10 minutes and you judge 3 times, 1 minute, 5 minutes, and 10 minutes. And at the end, you weigh the sample and you calculate the amount of water which the fabric has picked up. So at the end, you get actually 2 results. You get the grade and water content after 10 minutes.
Right. I think now, Rahel, we are ready for some questions. So let us first move to a quiet place.
Okay. Go ahead. I have already some questions to ask the guys.
All right. So we're back here at the Paternoster to show a bit of motion in the background. Martin has turned on the Paternoster.
Okay.
Okay. Yeah.
Okay, I think this is a question for Martin. What kind of tests are currently most in demand? What do you do most of the time? What kind of test?
Testing or
What kind of test is the most in demand, the most popular?
Oh, that's a very good question. It's still, I think, still just counting the numbers is still smart temp, but also all the WR tests, I think, is both of them are important for us for developing the new products, the new generations. So that's the two paths that we are running on at the moment.
How many tests are you doing a week? In an average?
Yeah, good question. I don't know, to be honest. We have done 4,000 orders last year, but that's not only our lab. That's also China and India. And you can multiply by approximately 5. So it's probably about 20,000 tests a year.
20,000 tests, that's quite a volume. Yeah, where are those tests coming from? And who sends, which countries or which companies send most of the tests? Is that something you can say? Let's say country.
Yeah, it's whole world. It's where the textile industry is. So textile industry mainly in Asia today. So it's lots of mills in China, Taiwan, India, Bangladesh, Indonesia, and then it's also the South and South America and Mexico, Guatemala countries, especially US brands are producing there. But it's all over the world.
Okay. I think there's another question, but I think that's more Renzo. It's about development. Are there any current development projects at HeiQ Lab that you can speak about, that you could say what you're doing at the moment?
Sure. I mean, we have key technologies which are durable water repellents, thermoregulation, odor control, and antimicrobial. We have already very powerful technologies, but we, of course, try to anticipate the market by bringing the same functionality, but with being more sustainable and by fulfilling the new regulations. So that's why, for example, we are pushing very strong on the Fresh family that is able to control the odor without being antimicrobial, which is added value that we are quite proud of. Of course, you will understand I cannot go very much into details, but as you know, if you know HeiQ, you know the pillars that HeiQ is offering to their customer. So we are pushing always not to get just a few percent more, but to really go to the next level. Bringing in the same functionality, but being, for example, more sustainable, more green, having more circular economy component in it.
Okay, thank you very much. We are a bit over time, but that's okay. It was really, really interesting. Thank you very much for the guided tour.
Welcome.
That concludes this presentation. Thank you, Martin, Renzo, and Hoikwan in the camera. Thank you very much.
Bye-bye.
Thank you.
Bye-bye.